As noted, we are using a 4-to-1 step-up transformer for phase 1. I'm not satisfied with the visuals on the last demo on the power inputs. So what we've done now is we've added a voltage meter on that phase 1. We see that on phase 1 we have 0.4 volts enabling 1.7 volts, and it's consuming 138.138 amps. Phase 2 has 1 volt enabling 0.133 amp, and phase 3 has 0.08 volts enabling 0.078 amps. What we want to be able to do in this video is go up in graduation of levels until we reach the arcing state of the Tesla coil. And I want to be able to see all of these meters. Okay, looks like 0.3. That looks like that should be satisfactory. We're going to go up. This has been running about 15 minutes with no field. The field hasn't been magnetized since yesterday. We'll go ahead and go up to a 10-volt field. When I say a 10-volt field, the variac drives a 4-to-1 step-down transformer. So in actuality, it's a 2.5-volt field. We have to divide by 4 for all of our variac voltages. And on this demonstration, we go up to a 40-volt variac to enable the Tesla coil to work. So we'll go now to a 10-volt field divided by 4. 10 volts didn't change much. In fact, that don't make any sense to me because that thing turned on. We'll go up now to a 20-volt field. We should start seeing some increase in stator line voltages. We're at 0.3, 1.1, and 0.9 volts on phases 1, 2, and 3. There's a 20-volt variac equating to a 5-volt field. You see our voltage has gone up to 2.4, 3.8, and 3.1 on phase 3. We'll go up now to a 30-volt field. 30-volt variac divided by 4, that's 7.5-volt field. The arc is starting to fire at a 30-volt variac. Let's turn that down to a 25-volt variac to get rid of the arc. That's about a 22-volt variac. Okay, from here we have 1 amp going through the bottom layer. With a 12-volt input. From a 4-volt input. Accounting for the 4-to-1 step-up transformer. It's pushing 1 amp through there. Correspondingly, phase 2 has 0.75 amp. Well, that went down to point. The amperatures are seemingly widely fluctuating. Okay. I'm surprised that we're going to go ahead and try to keep that voltage meter on there and go ahead and look up and gradually go into full Tesla coil operation. Hope it doesn't mess my meter up. Probably will. Go up to a 40 volt variac now. I'm going to take that meter out of there. The voltage kick back from the system across that transformer to run my meter. So it's not good for it. This meter always comes on by itself when there's high frequency. I'll put it up there anyway. Okay, we're at a 25 volt field. Going up to gradually up to 30. And now to 40. Now this being a 1 kVA transformer, we can see a problem in light of the fact that if it's a 1 kVA, it should only be pulling 8.3 amps through its primary, but we can see by the stator lines 1.3 and 1.2 that we got between 9 and 11 amps, and we're probably exceeding the amperages through the system. More importantly, we want to know what the voltages are in this operation. We are at a 6.8 volt multiplied times 4. We're at probably about a 27 volt input to the bottom layer. The bottom layer inputs secondary voltage to light the main arc gap there. But back to our meters then. We want to know that we got 7 volts on phase 1 enabling 2.6 to 3 amps. We got 60 volts in the middle, 55 volts enabling 1.2 amps, and we got 28 to 30 volts on phase 3 enabling 0.8 amps on the top. The strong arc gap goes to the weaker coil, boggles my brain. The water arc gap, we don't suspect much from that. Come on back out. Where are we at? Looks like something's happening there. We want to try this with gasoline, of course. See if I can get it steady on that shot again, please. That's as far as the zoom appears to work on that. Okay. Now that the strong, we'll go back and look on here to our top secondary arcing, which can't be seen. Hold on, folks. going to the weak coil. What we can't understand. Just the weak coil. There's the strong RPM coil. Here's the water gas coil. Why is the water gas coil much stronger? See non-volt again.